Okay, so here in this video, we're going to take a look at dilations. We know the existing coordinates and we want to find the new coordinates. So when there's an enlargement or a reduction about the origin, this is the key word, it has to be about the origin. You can find the new coordinates by multiplying all coordinates. Now when I say all coordinates, I mean x and y by the scale factor. So if I look here at my first example, it says find the coordinate of the vertices, meaning all of the angles, after a dilation with a scale factor of 2. Now that's 2 means that if I have a scale factor of 2, I know that this is an enlargement, getting bigger. And we can multiply all. So I'm going to look here. Look, it says C, and then it tells me the coordinate is 3, -2. Now if I looked up here at C, I'd be like, yep, that's right. That's 3, -2. Well, my new coordinate is going to be whatever 3 times my scale factor of 2 is. So 3 times 2 is 6. And then the y factor is going to be -2 times 2, which is -4. And we work our way through each one. So D is 3 and 5. I'm going to multiply by 2. 3 times 2 is 6. 5 times 2 is 10. And then for E, my pre-image is -3, -2. But when I multiply both of those by 2, I have -6 and -4. So we're just multiplying both coordinates. You got to multiply the x and the y to make that happen. So let's take a look at another one here. Here it says find the coordinates of the vertices after a dilation with a scale factor of 4. So 4, that's higher than 1. So this rectangle is going to be getting larger. That means we're going to multiply everything by the scale factor. If it's 4, everything multiplies by 4. So 0 times 4 is 0. -1 times 4 is -4. And I can do this for every vertice. 2 times 4, 8. -1 times 4, -4. Up next, 2 and 2, well, both of those would be 8. 0 times 4, well, that's still 0, and 2 times 4 is 8. So these are my new vertices. Now with that, I could redraw my dilation. I could show that enlargement by graphing those points on the exact same graph. Here, I'm not asking you to do that. I just want to show you what's happening to the coordinates. So we've got one more here, and it says find the coordinates of the vertices after a dilation with a scale factor of, and you notice that says 1/3. Because it's 1/3, that's definitely smaller than 1. It means I'm less than 100%. This is actually a reduction. We're going to make it smaller. But we use the same steps. We're going to multiply every single coordinate, both x and y, by 1/3. So first up is -9. Well, -9 times 1/3. Remember, we can set that up as -9 over 1. Multiply straight across. And that would be -9 over 3. Well, -9 divided by 3 is -3. So I'd have -3. I have 0 times 1/3. Well, anything times 0 is 0. For R, I have -9 again, but we just found that. -9 times 1/3, or a third of, or divide by 3, is -3. Now I have 3. So 3 times 1/3. Remember, that's 3 over 1 times 1/3. Straight across. 3 times 1 is 3. 1 times 3 is 3. 3 divided by 3 is 1. Up next, we have -3 instead of 3. Well, that would just mean that it's going to be a -1. 6, well, that'd be 6 over 1 times 1/3. We multiply straight across. 6 times 1 is 6. 1 times 3 is 3. And 6 divided by 3 is 2. We have one more, -3, 3. Well, -3 was -1, and 3 was +1. So with these new vertices, you could draw your new image. Again, we're just going to take the scale factor, regardless of what they are, x and y, and multiply them by the scale factor we've been given. So think both x and y, all vertices, and then you could graph these. If I graphed -3, 0, -3, 1, -1, 2, and -1, 1, I would have my new image.